to YouTube. Just as a reminder, YouTube is not picking up anything but my voice and the screen, so it's not picking up your voices or your faces. I'm going to try to remember to repeat your questions for that reason so that they're part of the recording, but if I forget, please remind me. Let me get this screen shared here. Number 2. There we go. So first off, I wanted to ask if you guys would be interested. This idea would take both volunteers and recipients. I've had a few of you contact me about notes for the class. Some of you are having difficulty, I know, taking your own notes because you don't have a printer or because technology won't cooperate or whatever. I was going to see if anyone was interested in having some sort of collaboration where people who are able to take notes would be willing to share them to maybe a site and icon. Like they have a collaborations feature that I was just finding out about. And that way, anybody who is interested could go there and download them. If you would be willing to share your notes with the class, please send me an email and we will work that out. If anyone else is interested, then hopefully that will make it so that we can all work together, but you're welcome, of course, to share amongst yourselves however you see fit. Let's see here. Can everybody see my screen? It looks like a hodgepodge of windows right now. Okay, hodgepodge in place? Okay, all right. Let me go to homework screen first. So yesterday was the recommended new due date for homework 3. As I had stated in the new syllabus, I'm not docking points of any kind for late assignments or quizzes or anything at this point. I know we all need a little bit of flexibility, but I do have recommended dates just to sort of keep you on track. Inside the homework portal, so I've logged in as one of my dummy logins who hasn't done much work this semester. I wanted to point out that at the bottom here is a compilation of all the points that you've earned this semester and how many total there currently are. So I haven't updated this with homework 3 yet. I'll hopefully do that after class. But if you are one of those folks who is trying to figure out how many points you need to get out of this semester, this is one way that you can do that easily. I believe I calculated the other day, there are 82 points possible now because of the work that I had to drop. And if you can get, I think it's 58 of those points, that is a passing grade. So that gives you a mark to shoot for if that's what you're aiming for. Are there any questions on homework 3 for those of you who are still working on it? No, I see one head shake. Cheryl gives me a thumbs up. No questions right now, folks, on homework 3? Okay, well, if you have questions, office hours are still available. If you're having trouble getting to SAS and Stata, please let me know so that I can help you. We've been able to successfully get everyone who's had trouble up and going so far, so hopefully that trend will continue. All right, then I will shut this off if there are no questions, and then I'd like to pick up in example 4, because looking at some code to be able to see how one would enter qualitative predictors, categorical predictors into the model will help us review some of those concepts again. So, all right. Are you ready to do this? Example 4? All right. So this is a big one. We haven't covered, this will be the first time that we've done anything that is applicable to homework 4. So we're a little bit behind on that score, but since there's no due dates, who cares, right? All of the homeworks are available to you if you wanted to work ahead. Otherwise, we'll just, we'll get through it one day at a time. Jen has a comment. Don't know about the drop-down answers. Looking forward to learning what I got wrong in the future. Well, that's a good attitude. I think I figured it out based on the point totals from last semester, that if you just get the red and green answers correct, that's 60% of the points. So even if you messed up every single drop-down answer, which I think is unlikely, you still are in pretty good shape in terms of percent-wise for that. So just as an FYI. So we're looking at the same data set that I've been playing with. This is the General Social Survey from 2012. Although this is I had worked with a subsample for the previous example so that we could make pictures and such. I have the full data set right here. The new outcome variable that we're going to be predicting rather than family income is personal income. So that's tied much more directly to your education than the income would be for your total household. So we're looking at, just to start with here, there is a variable in the data set for what the respondent viewed themselves as in terms of social or economic class. There's a low class, there's a middle class, and there's an upper class. So I wanted to make sure that those labels were part of the output. So this right here is in SAS. This is called proc format. This is something that's nice to add but isn't strictly necessary. What it does is tell SAS that in this variable, in one of the variables, every time a value of 2 would be relevant for the output, it's going to print this extended label instead. So you've seen this a few times this semester. If you want to add such things to your homework files, you're welcome to do that, but you don't have to. Um, in terms of making variables for the analysis, I am doing a few types of transformations in here to get the data set ready. This is more than what you would have to do for your homework. I just want to give you guys examples of how to work with data in each of these programs more generally. So starting with SAS, let me make this big here. First thing, and this is different between SAS and Stata. In SAS, when you're going to do transformations to a data set, so when you're going to do make new variables or kick cases out, filter cases out for whatever reason, you have to know to tell SAS, it has to know which data set you're doing that to. So this combination right here, this data and this set, this is telling it which data set to use, and it's also saving what you do to that same data set. If you wanted to make a new data set, you could, but it's usually not necessary. So this is example 4, is the name of the data set that was imported up above. So that was a step that happened right here. This proc import is importing the Stata format of the data to work with inside SAS. First thing I'm doing here is building an outcome variable. This part is something that I've done for you in your homework and will continue to do so, but just as an example of a linear transformation, we're going to be predicting personal income in thousands. So the original variable that was in the data set is right here. If I divide that by 1,000, that is the new column that I end up with. So it's always new variable equals old variable and transformations thereof. The same is true in SAS and Stata for that. Okay, with me so far? Okay. Um, these, yeah, please. Stata people, it's on the next page. Sure. Okay. What proc format does is apply a labeling system. It saves a labeling system that you can then invoke to attach to a particular variable, either just as part of the output or as part of the data set, and then it shows up in all the output. So at this point, all I've done is create a labeling convention that is called fclass and defined it as such. Later on, in the format statement down below, that labeling convention is then attached to the class 3 variable that I will have just created here. So that way, anytime that class 3 is part of your model or you ask for descriptives for it, those labels show up rather than just the numbers that define the categories. It's the way that it's stored is still 234, but there's a label. Yes. Yes, and that's just to save your working memory that you don't have to remember what two means in a given classification system. Because F stands for format. And so I have my own naming conventions that I've developed over the years. And you have to be able to differentiate what is the name of a column in a data set versus what is the name of the labeling convention that applies to the column. So a labeling convention is a format. That's why my names for those formats all start with F. And then what type of variable is the labeling convention for is the second part of the name. So this F class is my name that I made up. You can make up whatever name you want that is naming the labeling convention. But SAS has a few persnickety rules, one of which is that it can't end in a number. So that's why it's F class and not F class 3. And I have no idea why that is. Okay, is that better, Jacob? Okay, that's the way I labeled it. Yeah, you can have whatever conventions make sense to you. I tend to do the same thing over and over again because then it's sort of shorthand. When I look at my own code, I can read it more quickly. There are limitations on how long names can be in SAS. I want to say most of them are 32 characters. But if you use all 32 characters, then you have to type a lot more than if you use shorthand. So, okay. Um, So other things that I'm doing here, I'm subsetting the data to people who make less than 200,000 and who are under age 75 because age is going to be one of the predictors and there's very few people out in the data outside of that. Those are arbitrary decisions that I made just to build this example and to clean it up a little bit. This isn't something that you would need to do in your homework. I'm not going to ask you to delete cases, but if you ever needed to, this is an example of what the code would look like to do that. The other thing that I did is that class was originally four different groups, one of which only had like three people. That was the working class distinction, so I decided to merge those together. So this step right here combines what was class 1 and class 2 into class 2. So I'm creating a new variable that's called class 3. I think this is one of our first instances of conditional logic. So if the original variable is 1, then the new variable, class 3 equals 2. Otherwise, else, the new variable is equal to the same thing as the old variable. So what I'm doing is taking a column in the data set that is named class, and I am transferring that information to a new column that is called class 3, and it's 3 because there's 3 classes, and that was the way I decided to name it. If there was a value of 1, that becomes a 2, and otherwise the 2, 3s, and 4s stay the same. So in general, when you're going to recode a variable, that's what this is called, is doing a recoding. You do not want to touch the original column. You want to leave it intact, just in case you screw up or just in case there's any problems down the line. So you build a new column that has whatever new coding scheme that you would want to have. So three category class then is the variable that I'm going to apply the labeling convention, the format to. So the format statement, class 3 is the new variable. F class with a period after it refers to that naming convention for the labeling, what 2 means, what 3 means, what 4 means. Otherwise, this step right here, attention, attention, attention. You need to do this in homework 4. So I am taking in this example, it is a 3 category predictor, and I am making 2 new predictor variables out of it. I'll say that again. I am taking a 3 category predictor, and I am making two new predictor variables out of it, and those two new variables are what's going to go in the model. So this is the code that corresponds to the example that we've been talking about, where I have decided that my low group is going to be the reference group for the model. So if it's group 2, the new variable low versus middle is set to 0. The new variable low versus upper is set to 0 as well. That coding scheme that I personally have decided on, I made low the reference, means that the intercept is directly going to provide the predicted outcome for the low group. So these are two new columns that are being made in the data set. They're being set to 0 if the row is for class 2, which is the low group. If class is 3, then this predictor goes to 1. So L versus M is my way of saying that it's the low group versus the medium group. And in my naming conventions, the one that's first is always the one that gets the 0, and the one that's second is the group that gets the 1. The second contrast, the second predictor variable, low versus U, is low versus upper. That's still set to 0 because we're not at upper yet. Oh, thank you. Thank you. What are the predictors in the example? That is, yes. So there's one predictor variable that we're going to be talking about, and it's which class a respondent said they fell into, where they could be low, they could be middle, or they could be upper. So we're taking one column that contains a nominal variable, and we are creating two new variables out of that column that are going to be binary that we put in the model and fit the slopes for. Okay, does that help, Jen? See, there you are. Yeah, see, I'm like looking, where are the flowers? I know that's what Jen looks like today. Okay, there you are. All right. And yes, thank you for stopping me. It's unless my window starts blinking at me, I can't tell that there's a new question. So let me move the window so that it shrinks and that it'll start blinking at me if I miss something. Okay. Um, all this fun new tricks I'm learning. By the way, can you hear me better today? This is a different microphone than I had before. It's actually plugged in as a USB, so I am tethered. Ironically, this is the microphone that our department gave to us when they took away our landline phones, and they had us all pick up Skype. And I was like, oh, look at this. It's a microphone. Stuck it in a drawer. Joke's on me. Thank you, university, for this lovely microphone. I have never, ever had someone call me on Skype for business who actually wanted to talk to me and wasn't spam or looking for someone whose line that was 10 years ago. But just in case that ever happens, I'm ready. Okay, so back to the story here. Yeah, yep, nope, yep. It's creating them and setting them to values at the same time. So in previous examples, I had initialized it to nothing. This is a shorter way of doing that. What's going to happen is that if it were to come across a value that doesn't fall into any of these categories, let's say that there was a value of 5 out there that I didn't know about, because 5 is not covered under any of these conditions, the new variables would be set to missing for that. So when it creates this column, everybody is going to get a missing value who is not explicitly referred to as, if it's this class, here's your value. If it's this class, here's your value. So this little chunk right here, if I isolate just that, I'm making a new column called L versus M, and I'm setting it equal to 0. That is only going to happen, the set it equal to 0 part, if class is 2. Okay, does that help? Oh, okay. hmm So why did that happen first? Because one of my groups only had 3 people, the one group, and I decided to lump them into the twos. They were labeled working class, which I decided was sufficiently synonymous for low class to build a data example. Okay. Jacob, if you don't mind me sharing, by the way, Jacob is trying to do SAS coding on a project. And so he's fighting his way through the code in another context, and that's why I'm guessing there's more questions than usual about how this is working. Would that be a fair statement? hmm hmm Yeah, well, loading is an important first step, but yeah, just mhm. Yep. And I do that on purpose to try and minimize the program aspect of this because just figuring out how to use these programs is challenging enough. But yeah, most data arrive in a format that you have to do something to. You have to be able to manipulate the data to make new columns and to conditionally make new columns. So this example here that we're in, this if then is an example of what's conditional logic. So you're systematically introducing new variables as a function of what the existing variables say, more generally. Okay, did I answer all your questions, Jacob, and otherwise? For now, okay, that's fine, that's fine. All right. So you guys will get a chance to do this in homework 4. The only catch is that homework 4 has 4 groups. So we talked about this before, but let's review it. If I have, we'll start with the lowest. The first example that you've done of this type of thing was in homework 3 at the very end. If you have 2 groups, if you only have 2 groups, so your predictor is which group are you in, there's 2 potential means, one for each group, a mean outcome, I should say more specifically, and there's only one mean difference. Because there's only one mean difference, there's only one slope that goes in the model. It's the difference of how the one group compares to the 0 group. What I have here highlighted is 3 groups. If there are 3 groups, there are 3 means to be accounted for by the model, and it takes 2 predictors to have the slopes to go into the model. So 1 intercept and 2 slopes equals 3 parameters that are perfectly going to recreate my 3 means. If there's 3 groups, there's 3 possible pairwise differences between groups. Pairwise mean between each 2. 2 of those differences are going to be given directly. So in this case, what's given directly is the difference of how middle differs from low, because that's how I've made this variable, and the difference of how upper differs from low, because that's how I've made this variable. That's what they mean. Because I have decided on this system of zeros and ones, that is what they mean. So there's one more comparison that is implied, but isn't given directly, and that's the difference of middle and upper. And what's going to happen is that the slopes that are estimated for these variables, the difference between them is going to give me that missing difference. That's what we'll see happen in just a minute. Okay, does that much make sense? Any of that you want to hear again? Okay, so in your homework then, if you have, this is where we can all play along, even on mute. If you have 4 groups, how many slopes do you need? How many new predictor variables do you need? Yes, looking at my camera. There we go, we got it. 3. Yes, very good, everybody. So that means that in this coding, you would have to have one more of these. So you would have like group 1 versus 2, group 1 versus 3, and then you'd have one more set that goes in here that would be group 1 versus 4. Yes, if there are 4 groups, and by the way, groups and categories are the same. It's a categorical predictor, but most of the time when people think about categories, they're thinking about groups of people, and so that's where the language gets a little fuzzy, but categories and groups are the same. If there are 4 groups, there are 6 possible group differences. There's 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4, and 3 to 4. Got them all. The model only takes 3 slopes to give you all 6 differences. So it requires creating 3 new binary variables where one of the groups is designated as the reference, and the instructions in your homework will tell you which one. It'll be the first one. And that group, all of their slopes are set to 0. Then each variable gets turned on, so to speak, set to 1 when it's that group that is to be compared. So low versus M is going to become how the medium group differs from the low group. L versus U is going to become how the upper group differs from the lower group. The difference of the slope for each of these variables is the missing difference of how upper differs from middle. And we'll see that in the estimate statements below. Okay, does that help? Is that good? Ish? I'll take ish. Ah, yes, yes. So we're just setting up the predictor variables at this point that give us this system of how do we get the differences between the groups. No, that doesn't hold. I'm sure there is a formula, but I don't know what it is off the top of my head. Um, the formula that you can remember is that the number of slopes you need is the number of groups minus 1. Because the minus 1 is because you already have an intercept. Hmm. Uh, I think it's a factorial problem, if I'm remembering correctly. Like, you remember the exclamation point? Like 3 exclamation point is 3 factorial. I think it has something to do with that. I'd have to look it up, to be honest. I haven't done that sort of math in a while. But how about I look it up and get back to you? Because there is a formula. I'm quite certain of it. Hmm. Yeah, yeah. There's not. Yeah. Yes. Yes. And I'm gonna to put it out there to start with. Last semester, I ended up going over the coding scheme after people had tried it and had struggled with it, and I'm happy to do that again. But I want to just get people started. But yes, this is we're going for generalization of this coding skill. There is actually a way to let the program do this for you. I am deliberately not teaching it to you. Not because I'm mean, not because there's a pandemic, but because I want you to know what it's doing under the hood. That way you won't screw it up because it's too easy to screw it up if you don't know what's going on. It'll be at the very end of the semester. I think I finally broke down and brought it out in the last lecture that I gave last semester, which is one that we're not going to get to, but I put it on the syllabus so that you can go check it out if you're interested. And of course, if you come to any of my other classes, I will be happy to show it to you then. So, which you are all welcome to do. All right. Last thing in here, this is another thing that I'm including for your reference, but you're not going to be expected to do this. This is how to subset your data to only those people who have complete information with respect to the variables in the model. So what's going to happen if you don't do this is that anybody who is missing personal income or who is missing what class they're in would get booted. Someone's typing at me. Let me see what they said. Booted meaning dropped out of the model. If you want your models to be comparable, no matter which combination of, you want them to have the same people in them, then you can subset. Would it look like this? Hang on, Jacob. I can't read it. There we go. Yes. Okay, Jacob just did your homework for you. Congratulations. That's okay. This is only one small step, but yes, that's the extension of the coding logic to it would be four categories is that you've got. Um, mhm, mhm. Yes, yes, that's a good way to think about it. So then there's four rows of code because there's four possible groups that um, you would have to do to condition on, and then there's three new variables. So you've added one column, so to speak, in one row. And question from Cheryl: would you ever have two number ones in the same row? Potentially, yes. Stay tuned. So the cool thing about this, there was a word that a student used last semester. She called it sorcery. Um, I like that word quite a bit. It's you can set this up however you want to tell it, like you can ask it to give you whatever comparisons you want. The coding scheme that I'm showing you here is sort of the entry point. It's called dummy coding. A variable that is just a zero or a one is called a dummy for reasons I don't know why. That's just one of the conventions in the field. But there are other coding schemes by which you can tease out different patterns of differences. And so, yes, in some of those schemes, you would have two number ones in the same row. Stay tuned. Okay. Stata people, your turn. So Stata only allows you to have one data set open at a time, at least in up till through 14 and 15, which I think is what you have access to inside the virtual desktop. So here's an example of making our outcome variable as a linear combination. It looks exactly the same as SAS except for the word gen in front. So anytime you want to make a new variable, you start with gen, and there's no semicolons. The coding scheme for the dummy codes. So this is the step where I took class 1 and made it class 2 in the original variable. You don't have to do that. Here's the part that you would have to do. Um, it's the same idea as what's in SAS, but the code just looks different. Um, I am doing this a little bit differently than what I did in SAS to try and save a few steps. So I am generating these groups to start at 0. So I'm making two new columns and I'm setting them to 0 for everything. And then I'm going to go in and change them to the values of ones that I need for each specific group. So the instruction is replace, meaning take the value that was there and stick a 1 in instead if it's for class 3. So I'm going to turn the L versus M to 1 if it's class 3. And note this here, equal, that's not a typo. It's really equal. What it means is it's an equivalency step. So it's a condition, like if it is 3, not make it 3. So the single equals means make it a 1. The double equals means if it is 3, then do this. So the end result is the same as in SAS. I'm just doing it in fewer steps. So it's turning this predictor variable, the first one, to 1 if class is 3, and turning the other one to 1 if class is 4, and then it will be zeros either. Repeat that part again. Uh, yes, a single equal is make it equal to this. So like I'm saying, take that column and turn those values that were zeros into ones. Change the values. The double equal is a condition. If it's class 3, so I'm not setting anything to 3, I'm not changing the information, I'm just evaluating it for a condition. So this part here, if class is 3, is exactly the same thing as this right here. If class is 3 in SAS. It's just that SAS doesn't use the double equal versus single equal convention. I've seen that in a few other programs too, that double versus single thing. M plus comes to mind, for instance. Okay. So then you would have one more of these gen statements in homework 4 because you'd have to make 3 slopes, and then one more of these conditional statements because you'd have one more group to account for to turn that last slope to 1. And then the function to kick out cases that are incomplete looks right here. It's a fancier function.Egen generates a new variable that's called nmiss, and there's a function here. Functions are built-in math. So row miss is an option that counts the number of missing variables in this list, so the number of values that are missing, and then if that number is greater than 0, it drops them out of the data set. Okay. So any other questions on syntax or concepts in terms of making new variables? Okay, I will take that as a no. All right, so first things first, even though what we're eventually going to be doing is modeling, it's good to get a sense of the data that you're going to model. So this is Another step that I would do in life that I'm not asking you to do in your homework, just get frequencies for each of the categories. How many people are in each self-rated class? So proc freak is how we do that in SAS. It's tabulate in Stata. That gives us a breakdown of the counts of people and percentages that are in each category. So we have about 60% of the people said that they were either low class or working class. That's the low group. 38% of the people said they were in middle class. And note that only about 3% said they were in upper class. So why this is important to know ahead of time? In terms of statistical power, in terms of us being able to find an effect that's really there, that power is going to be less for groups that have fewer people in them. So in trying to compare the upper group against the others, we have a lot less power to compare them to the others because there's a lot fewer of them. Their mean is going to be noisier. Their standard error is going to be bigger because there's so few people. So that's just something to keep in mind, that the model is going to reflect the data that are here. And so if, for instance, I really cared about this group, I probably should have went out and tried to oversample them to make sure I have enough people to compare them. So that would be a sampling strategy you'd have to keep in mind to begin with. Do you care about groups that are underrepresented? If so, you may need to overrepresent them so as to have adequate power to look at those types of persons. Also looking at the means for the variables, the outcome variables. So proc means for the outcome variable, that is summarize in Stata. So the mean is 17. So in this data set, on average, people reported personal income of about $17,000, and the variance is 190. Those two numbers are going to show up in our empty model in just a moment. Here's some pictures. This is yet another thing that you're not going to need to do in homework, but I wanted you to have code that shows you how to do it. These are histograms. So proc univariate is how you can ask for a histogram in SAS. Looks like I dropped the histogram code here. There should be another line that says histogram. I will fix that after class, but for now, histogram, and then that variable is what it should say, and a semicolon, and it should be blue. This is the picture that made. Stata has a histogram option. Okay, so this is what the distribution of personal income looks like, just the marginal distribution. How would you describe that? You can type or you can talk. Take your pick. Yeah, positively skewed. It's definitely a quantitative variable. Positively skewed, yep, bounded at 0, because you can't make less than $0. In terms of using this analysis, in terms of fitting a general linear model to predict this quantitative outcome, do you remember what we're willing to believe about this outcome? What kind of distribution is the outcome supposed to be from? Starts with an N. Normal, yes. So does this look normal to you? No. Now, is that necessarily a problem? We don't know yet. What we have to be willing to believe to use a general linear model to predict a quantitative outcome is not that the outcome is normal, but that its residuals are. Residuals are how far off your predicted outcome is from the real one. What does normal look like? It looks like a hump. Looks like, is that a pretty good normal? Yeah, I'm doing the best I can. I could get out paint, but yeah, it's the bell curve, so to speak. Yes, the bell curve. By the way, if you want to sound really smart and irritate people, you describe normal as Gaussian. Okay, there's your esoteric stat word of the day, Gaussian. Another one I also like, error, by the way, is stochastic. That's a fancy word. Error is stochastic. Normal is Gaussian. Besides normal, speaking of other fancy stat words for the residuals, they are supposed to have constant variance across the predicted outcomes. The term for that is homoscedasticity, and they're also supposed to be independent. So the constant variance and the normality of the residuals, we don't know yet. What's the word she used, the smart language? Gaussian is the normal distribution. That's Gaussian. It was because Gauss is the one who's credited with inventing it, yet another dead white guy who has stuff named after him. And so it's Gaussian. Or stochastic means error. Stochastic. There we go. I think that's correct, or something very near. And homoscedasticity is constant variance. So the design of the study should give us a clue as to whether the residuals are plausibly independent. This is a sample of individuals. There's supposed to be only one person per family. There's not supposed to be groups of people. So independent residuals is plausible. If I knew that these people came from they were nested in, say, neighborhoods or school districts or religious groups or anything else, I would have to add that. I'd have to change the model to incorporate that, but they're not, as far as I know. So independent residuals, and the residuals are supposed to be normal. So I'm belaboring this point because this is a very common misconception from people who are learning statistics. They are taught that in order to use these models, the outcome has to be normal. Meaning this, what we're staring at right now, has to be normal. It's not true. The residuals have to be normal. And in the effort to try and make this outcome normal, one might try to transform it. So a nonlinear transformation in particular would take this tail, the people that make a lot of money, and it would reel them in, squish them back into the other people, and potentially distort the effects that we're going to see in the model as a result. So we won't know if the residuals are plausibly normal with constant variance until we're done modeling. So I put that out there as it looks like it could potentially be the case to the extent that the model can predict why some of these people make a lot more money, relatively speaking. If the model can predict it, then that positive skewness goes away and it's not a problem. So we shall see. Okay, I think I hear a vacuum running upstairs. If so, that is a miracle. All right. Yeah, it's too cold to play outside today, so I'm really feeling for my husband having to entertain Huey for 4 hours at a time. It's very challenging. You better get that cleaned up before your mom comes up here. Yeah, he knows my proclivity. I'm one of those like super, super neat people. Um, I walk around picking crumbs off the floor or pieces of lint, like it just drives me crazy. And so I tell him that if you don't clean that up, mommy is gonna lose her mind. Because lose your shit is probably not appropriate to say to a 5-year-old, even though that's really what I meant. Anywho, all right, are we ready to do this? and not lose our shit, so to speak? All right. So, something you will, I don't remember if I asked you to do this in homework 4, but I know I asked you to do it in homework 3. So you just learned how to do this. An empty model. So empty model is, it gives you a baseline. If you don't know anything else about a person, it returns as the best guess for what each person's predicted outcome is the mean. That's going to be my fixed intercept beta 0 right here. And the E at this point is how far off each person's real outcome is from the one that's predicted, as the reference is the predicted. That's just the mean. So the E, the variance of the E's across people is all the variance in the outcome. So what we're going to get back is exactly the same information that we saw in just running descriptives for this variable. Here's the sample mean. That's going to be my fixed intercept beta 0. That's what it's going to become. Here's the sample variance for this predictor, and that is going to be the mean square error or mean square residual. So 190 is a number that conveys all of the reasons why some people make more money than others. That's how much variation is in our sample. Now, it's hard to think about variance intuitively because it's in squared units. Because some people are above the mean and would have a positive residual, and some people are below the mean and would have a negative residual. So to avoid positives and negatives canceling each other out, we use squared terms. If we want to unsquare it, do I need to get my calculator out? Or can I just stare at what I have and have that information magically be provided? SD, says Cheryl. Yes, right here. 14-ish is the square root. Okay, so this number, standard deviation, is arguably more intuitive. It is how far off, on average, each person's income is from the sample mean income. So 2 standard deviations around the mean on either side would create a 95% confidence interval that describes what 95% of the sample would be expected to have in terms of their individual incomes. So on average, people differ from the mean by about $14,000. That 14 squared is 190. So it's the collection of differences in that sample across individuals in that sample. That information is given to us directly by the empty model. So here's the 190. That is labeled as mean square error. Here is the fixed intercept beta 0, the 17, that's the sample mean. Next to the sample mean is the standard error. So that is the standard error of the intercept, how far off that sample intercept would be from the population intercept on average across samples. So if we did the same study over and over and over again, the confidence interval that is created by that standard error, where the estimate is in the middle, tells you the expected variation of that sample mean across samples. This is the range in which 95% of the time the mean would be found. Okay. Now we have a model. So I have on here the same stuff that was from the slides. Here's my model. I think that personal income, income sub I, so that's my Y, income for each person, is going to be a function of an intercept, So that's a starting point. And it's going to be a function of which class you are in. So to know what these betas mean, to know how to interpret them, I have to know how these predictors are coded. Intercept is always, always, always the expected outcome when your predictors are 0. Under my coding scheme, L versus M is 0 when I'm talking about the low group or the upper group. L versus U is 0 when I'm talking about the low group or the middle group. The common denominator in which they're both 0 is if it's the low group. So the low group's mean is going to be given directly as the fixed intercept. So if you want to see the math filling in the values for the predictor variables that I created for the low group, that's what it would look like. To get the mean for any other group, homework question, is a linear combination. So to get what the mean is predicted, the mean outcome, I should say more specifically, I keep saying the mean, but it's shorthand for mean outcome. For the middle group, I pick up the effect of beta 1. For the upper group, I pick up the effect of beta 2. So these are model implied outcome means that are not given to you directly as intercepts or as fixed effects. They are linear combinations. These will need to be requested as an estimate statement in SAS or as a lincom statement in Stata. So I've got 3 fixed effects in my model, 3 betas, a beta 0 intercept, and 2 beta slopes, 1 and 2. Those 3 fixed effects perfectly recreate all 3 means. If I know what the mean for each group is, then I can know what the mean difference is. Can know, that's a new word, I just made that up. I can know means I can figure it out. So here's the first one. The difference of the middle group versus the low group. Middle is first. Up here I found out that middle is beta 0 plus beta 1. So there it is. Up here I found out that the low group is just beta 0. So the beta 0's drop and I'm left with just beta 1. Same pattern happens in low versus upper. I'm left with just beta 2. So that is to say that 2 of my differences are given directly by the model slopes. Beta 1 is the difference of how the middle group differs from the low group, with low as the reference. Beta 2 is how the upper group differs from the low group, with the low as the reference. To get the missing one, it's a linear combination. It's the difference between the slopes. So the slope for the upper group was beta 0 plus beta 2. That's right here. The slope for the middle group is beta 0 plus beta 1. The beta 0's drop, and I'm left with beta 2 minus beta 1 as how the missing pairwise comparison can be found. It's in the model. So in your homework, if you have 4 groups, if I have 4 groups, I have 3 slopes. If I have 4 groups, I have 6 pairwise differences. That means the 3 slopes are going to cover 3 of them, and the other 3 would be linear combinations found exactly the same way as this. The difference between the slopes for those non-reference groups. Okay, how we doing? Thumbs up? So here's how to make SAS do this sorcery. So same code that you already know. You're not learning any new code in terms of modeling. Proc GLM, proc general linear model. The order on this line after model comes the outcome variable. So before the equals is the outcome, the same as it is in writing the equations. It's parallel. The predictors go after the equals. And this is the first instance that you guys have seen where there's been more than one predictor. So conceptually, there's one predictor in that I have this variable for which group you're in. That's like one piece of information about a person is what class they rated themselves to be. But in order to differentiate my three classes, I need two predictor slopes. Solution means give me the answers because crazy as it sounds, that's not a default. And the second part of this refers to the confidence intervals. CLParm requests confidence intervals for each parameter, and alpha equals 0.05 means make it a 95% confidence interval. You can change that if you'd like, but that's not something I'm going to worry about too much. The next part here, I have illustrated how to get all three means and all three mean differences, even though some of these are redundant. I wanted you to see the full pattern. So let me try and fit all of this on the screen at the same time here. This part right here, getting the mean for each group, is this right here in SAS. The word that shows up on these estimate statements, so estimate is a SAS command, that's why it's in blue. Inside the purple is a label that you provide. So write whatever makes sense to you that tells you what you're asking it for. The word intercept refers to what the fixed intercept estimate is going to be. So it's like a placeholder for whatever the intercept estimate is going to be from the model output. I need one of those to form each mean. There, highlight that again. Then, what value do I want to give the variable that corresponds to this L versus M slope? If it's the low group, I want a 0. If it's the low group, I want a 0 here. If it's the middle group, this turns to 1. And if it's the upper group, the second one turns to 1 instead. So the first statement is redundant with the fixed intercept. Even though it's redundant, I find it helpful in practice to write these things out because you don't have to go to the work of figuring out what your model parameters mean if you write these notes to yourself. It's like your trail of breadcrumbs. The differences then. The first two differences of the low group versus each of the others is given directly by the model as a slope. And that is true down here too. So these are redundant. They would be already on your output as the effect for beta 1, as the effect for beta 2. The one that you have to ask for that's different is the mean difference between the two non-reference groups. That's how you take one slope and subtract another slope from it. So beta 1 is the first one here. This is beta 1. And beta 2 is the second one. So I can say minus beta 1 plus beta 2 and it would be the same thing. Last but not least, if you want standardized effects, that is a proc reg command instead. And with that option, and that adds one more column to your output. Unfortunately, proc reg does not allow any of these estimate statements. So that is one thing at which Stata has it beat. Stata regress allows the standardized effects and the lincom statements. So the first three statements in Stata give you the mean for each group. The second three statements give the mean differences. And in Stata on the regress line here, order matters. So the first word after the regress command is the name of the outcome variable, followed then by all of the model predictors that you want. And when you're done listing the predictors, there's the comma that separates the options. And so level 95 is asking it to do confidence intervals for the 95% range, same as SAS. This C dot thing, this indicates to Stata that it is a quantitative predictor. All of these predictors are being treated as quantitative, and that's necessary under certain commands to make it do math with them. I've gotten used to just including it no matter what so that Stata doesn't yell at me. The three lincoms here, the analog to intercept is this underscore const thing. That's the fixed intercept. We need one of those, and then we fill in the zeros and ones that go with the coding scheme to figure out which group we're asking for information for. Okay. Questions on that or any of that that you want to hear again? So how would this have to change to get your homework right? That's a good question, right? That's a relevant question. Add more info, correct. First thing that would have to change, so if I copied this, pasted into my syntax, first thing I've got to change the name of the data set. That goes to your homework data set. The name of the outcome. And how about in here? I need one more predictor, right? Because I'll have 3 slopes for 4 groups. If I have 4 groups, I'd have one more mean to be found. And up to 3 more mean differences that would go here. I don't believe I asked for all of them in the homework, but as many as I asked for, you would want to find. In Stata, you don't have to worry about the name of the data set, but you would have to change the name of the column that holds the outcome variables, as well as adding in one more predictor here, potentially one more mean here, and however many other mean differences are being requested. B, there'd be, mhm. Because in your homework, the setting is training in golf, and there will be participants who are in a control condition. They were trained in regular golf only, they were trained in mini golf, or they were trained in both kinds of golf. So relative to control, you will be examining the effects of training. Beta 0. Good question. Y hat is what? Do you guys remember what Y hat means? Hat, a little TP over it. There you go. Yeah. Predicted outcome for whatever kind of person, right? Estimated, predicted. Yep. I would take, you can say predicted outcome, estimated outcome, or expected outcome. You can say any of those words. So these 3 lines right here and these 3 lines right here are all creating Y hats. Because this model allows for three different y hats, a y hat for the low group, for the middle group, for the upper group. If we had additional predictors, such as, say, their age, their gender, stuff like that, the Y hats would be further customized based on age, based on gender. So there'd be really an infinite number of Y hats possible because it would depend on your exact configuration of predictor variables. In this context, there's only three Y hats because there's only three possible predicted outcomes, three groups. You, after this, this is the first third of it. Yep, yep. There is the arguably homework should help you learn. That's sort of what I was going for, is to provide you with practice. I think if you have the time to do so, I think it would be good to do it in chunks because in this homework it's going to be three separate analyses that correspond to sort of the three sections of lecture four. There's the multiple group predictor example, there's going to be a quadratic example, and there's going to be a piecewise example. And so doing, yep. Yep, and we haven't looked at the output yet, but once you figure out this much, once you figure out how to build the variables, put them in the model, and ask the model to spit out everything you need, then just plugging in the numbers into the portal is pretty straightforward from there. Interpretation is the trickier part, but it should readily follow if you label your things the way that correspond to the homework. So one thing I would encourage you is, like, I'm labeling this low mean, for instance, because that's what it means in this context. I would go to the trouble to change these labels so that they correspond to the groups in your homework. That way it makes it easier to follow rather than just using my arbitrary titles. Yep. Last question before we adjourn. What am I doing? What's another name for this modeling procedure in which I have a quantitative outcome predicted by a grouping variable? Remember what this is called? Starts with an A, N, ANOVA. Yes, it is, Melissa. You win the prize. This is an analysis of variance. That's what we're doing. So, just in case anyone asks, that's what we're doing this week, analysis of variance. All right. Any other questions before we adjourn? All right. Office hours start again at 3:15 if anyone wants to come. Otherwise, I hope you all stay safe and have a good day. See you Thursday.